Okay, ladies and gentlemen, here we are with operations with functions. We had a look at what functions are. Hopefully you got a pretty good grasp of what functions are. Now we're looking at operations with functions, section 1.2 in your textbooks, okay, or in your workbooks. Before we continue here, we need to look at what function notation actually is, okay? You've seen equations that look like this, say y equals 2x plus 1, right? Hopefully you remember that we can rewrite this as f of x is equal to 2x plus 1. We basically replace y with f of x. These are interchangeable, okay? We can essentially say that y is equal to f of x. It's just a different type of notation. So this is where your function will be when x is a certain value. F is kind of a convention. We can have g of x, we can have h of x, we can have k of x. It's all about identifying functions. This could be a quadratic function. G of x is a quadratic function. F of x is a linear function. It's just a way to identify different functions because realistically you're going to have more than one function working on any given thing. So if you think about building a bridge, you've got the tensile strength of the material, you've got the wind possibly, you have gravity, you have the force of the vehicles on there. There's four things right away that have to be taken into consideration. So we need a way to identify which function is which, okay? And we do that using function notation. So we are now going to be looking at operations, which means we're going to be adding, subtracting, multiplying, and dividing functions, okay? And we start off by what we call a sum. Now, if you have f plus g of x, we're adding the f function and we're adding the g function. It can be written as this, f of x plus g of x. Similarly, if we have a difference function, f minus g of x, that's simply looking at f of x minus g of x. We look at a product, which is a multiplication. F times g of x is f of x, the f of x function, times the g of x function. And if we look at a quotient, which is division, if you go f divided by g of x, that's the f of x function divided by the g of x function. Now, since we have a denominator here, we have a built-in restriction. We have something that cannot exist. We know that this denominator cannot be 0. So g of x cannot be 0, and we have to state what we call restrictions. Okay? So now let's look at a couple of examples here. We're going to look at solving things algebraically. Okay? So first of all, f of x is equal to 2x plus 1. If I gave you, let's look at function notation again. How about I said f of 3? What does that mean? That means that the f function, when x is 3, what do? We plug in the 3 in for x. So it's going to be 2 times 3 plus 1, which is 7. So if you think about a graph, when your x is 3, right, your function will be 7. All right? So keep thinking about the graph. You got to keep thinking about what the graph means. Okay? So let's look at f plus g of x. That's the same as f of x plus g of x, which is the same as saying, well, f of x is 2x plus 1 plus g of x, which is x minus 3, and we simply combine them. 2x plus x is 3x. 1 plus a negative 3 is minus 2. There you go, you're done. Similarly with subtracting, it's going to be 2x plus 1 minus x minus 3. 2x minus x is x. 1 minus a minus 3 is a plus 4. Okay? So this would be f minus g of x. All right? Let's keep going. Let's look at the multiplication now. What about if I had f times g of x? That's going to be 2x plus 1, which is my f function, right? 2x plus 1 times my g function, which is x minus 3. F of x times g of x. F of x times g of x. How do you multiply two binomials? We FOIL them out, right? First, 2x squared. Outside, minus 6x. Inside, plus x. Last, minus 3. The final step would be combining all these terms, and you end up with a trinomial. Okay? Let's finish this off. We'll do the quotient. Last one is the quotient. We'll go f over g of x. That simply means that you have the top, which is f of x, over the bottom, which is g of x. In this case right here, we can't simplify this any further. There might be situations where you can. You got to factor it, cancel common factors, see if you can simplify it. But what we can do here is state the restriction. since the g of x is in the denominator and we have a variable in the denominator, it means we need to state what that variable cannot be. We need to state the restriction. We know that it can't be 0 on the bottom, so x minus 3 can't be 0, which means that x can't be positive 3. That's the restriction that we need with this final quotient, okay? Now your functions will be more complicated. You might have 3 functions as well, okay? You might have to do things 3 times, but the process is exactly the same, okay? The algebra might become a little bit more complicated, and we can deal with that when you have those issues, okay? Now, the next thing we're going to do is we're going to look at solving this graphically. What that means is that you're going to have 2 functions possibly. Here's an f of x function, here's a g of x function. What we want to do is find out what happens when you combine these. Now, since you are looking at the whole function, you need to identify what happens at specific values. So what we can do is we'll leave this here and we'll make a quick table, okay? We'll look at f of x, we'll look at f of negative 4. When f is negative 4, it's positive 2. When f is negative 3, what happens when f is negative 2? When f is negative 1, okay? When f is 0. And then when f is positive 1, when f is positive 2, when f is 3, when f is 4, how far do I go? And then when f is 5. So from minus 4 to 5, okay? And let's just write down all those values. When it's negative 3, it's 2.5. When it's negative 2, it's 3. When it's negative 1, it's 1.5. When it's 0, it's 0. When it's 1, it's equal to 1. It's equal to 2. It's equal to 3. It's equal to 4. It's equal to 5. Now we have all the values of the f function through the whole thing. Let's do the same thing for the g function. G of negative 4, g of negative 3, g of negative 2, g of negative 1, g of 0, equals, all the way down here. And then we go g of 1, g of 2, g of 3, g of 4, and g of 5, all the way down here. So now we've got all the g's covered from negative 4 to 5. Well, negative 4, it's negative 2, negative 3, negative 2.5, negative 2, negative 3, negative 3.5, negative 4. And then at 1, it's negative 3, negative 2, negative 2, negative 2, negative 2. If you make this table represents all the values in this graph. You no longer need the graph, really, but what we do here, we'll use the graph. I'll leave it off to the side here. Now, what happens if I want to say, okay, f plus g of x for this graph right here, okay? Well, what we do is we look at the values. So let's get another graph here. I'm going to try and organize this here a little bit better. Let's have a look. So if I'm going to do f plus g of x, okay, that means that I'm going to take these values and add them. At negative 4, f is 2. At negative 4, g is negative 2. Add them up, you get 0. So at negative 4, right, at negative 4 here, you get 0. At negative 3, it's 2.5, and you're going to add negative 2.5, so it's also 0. At negative 2, it's 3 and negative 3, also 0. At negative 1, 1.5 plus negative 3.5. That gives me a negative 2. At 0, it's going to be 0 plus negative 4, so I got negative 4. So these two functions here combine to give me this graph on the left side of the axis. Now let's keep going. F is 1 plus negative 3 is negative 2. 2 plus negative 2 is 0. 3 plus negative 2 is 1. 4 plus negative 2 is 2. 5 plus negative 2 is 3. This is the rest of my function. So these two here combine to give me this. This would be f plus g of x. Okay? Now similarly, minusing, it would be 2 minus, right? So let's look at f minus g of x. Okay? That would be 2 minus a minus 2. 2.5 minus a minus 2.5, 3 minus a minus 3. Be very careful with your negatives because you can see these are turning into pluses, right? Well, let's check it out. Let's try one right now. So 2 minus a minus 2 would be 4. So at negative 4, it's 4. 2.5 minus a minus 2.5 would be 5. 3 minus a minus 2, 6. 1.5 minus a minus, so plus 3.5 would be 5. And then 0 minus a minus 4 would be 4. It jumps back down here. So let's jump at 1 minus a minus 3 would be plus. So we got a 4. 2 minus a minus 2 is a 4. 3 minus a minus 2 is a plus. We go to 5. 4, and then we got 6. And then we got 7. So if we subtract these functions, you end up with another different weird function. Okay? Similarly, we can multiply them. This becomes a little more complicated sometimes, right? So fg of x now. So we're going to multiply them. At negative 4, 2 times negative 2 is negative 4. At negative 4, we have negative 4. And then at negative 3, 2.5 times negative 2.5 is negative 6.25. So it's 6 1/4. Gets a little more complicated here. 3 times negative 3 is negative 9. I guess that's right about here, right? And then I got 1.5 times 3.5. We start getting into numbers. I don't know what that's going to be. It's going to be a decimal. 0 times negative 4 is 0. It's going to be 0 again, so it's going to come back up. And we keep doing this over and over for every value. Once you get good at this, you might actually be able to look at the graph and look at this. If you're going to add 2 and negative 2, you can see it's 0, right? 2.5, negative 2.5, 0. 3 and negative 3, 0. 1.5, 3.5, negative 2. 0, negative 4, negative 4. There's other ways to do it as well. It all depends on how well you understand this, okay? Now, if we do the quotient, all that is different is we got a little bit trickier math. 2 divided by negative 2 is negative 1. So if we looked at making a quotient 1, right? A quotient 1 at negative 4, it's 2 over negative 2, which is negative 1. And then it's 2.5 over negative 2.5, which is negative 1 again. 3 over negative 3 is negative 1. 1.5 divided by 3.5. Looks like about a third, negative a third, about. And then it's 0 divided by negative 4, which is 0. And then it's 1 divided by negative 3, which is negative 1/3. Then it's 2 divided by negative 2, which is negative 1. 3 divided by negative 2 is negative 1.5. 4 divided by negative 2 is negative 2. 5 divided by negative 2 is negative 2.5. So here we have my quotient function. So now we're looking, folks, at operations with functions. We got sum and difference, product and quotient. With the quotient, we need to state restrictions. We can combine them either algebraically or we can combine them graphically.